In our previous discussions, we explored three main categories of tasks you can ask a large language model or LLM to perform. That's writing, reading, and chatting. Since LLMs are trained to predict the next word, it's not surprising that they excel at generating text. Many writing tasks can be easily accomplished using a web user interface. I believe writing tasks will be immediately helpful for us. When it comes to writing tasks, we usually begin with a prompt, which is a short input that guides the model to create a longer piece of text. So let's take a closer look at some of the writing applications available. We often use the web interface of large language models as a brainstorming partner. For example, if you ask it to come up with five creative names for peanut butter cookies, it can generate some really fun suggestions. So, which of these would you prefer? If you ask it to brainstorm ideas for increasing cookie sales, it can come up with several suggestions for you to consider. You can then review these ideas to see if any might be helpful. Additionally, you can use a large language model like the web interface version to help you write marketing content or other text. Let's start with an example. If you ask it to write a press release announcing the hiring of a new chief operating officer or COO for your company, it might generate a generic statement like company name welcomes new COO's full name. So this is a basic press release. When writing your prompt, it is important to provide a large language model with more context or background information. If all it has is a simple request, say to write a press release, it won't know anything about your company, the new CEO's name, or their qualifications, resulting in a very generic response. So if you receive a basic press release like this, don't worry, you can simply update your prompt with more details to get a better result. Now, let's look at one more example. If you provide specific information for a press release, such as the CEO's bio, the name of your company, and some details about your company, the model will generate a much more detailed and insightful press release about the COO joining your organization. We often don't get the prompt right on the first try, like we saw earlier when I asked for a press release without any context. And that's completely okay. If the result isn't what you were hoping for, just revise your prompt and try again. Another writing task we use LLMs for is translation. In fact, some large language models available through web interfaces are surprisingly competitive, sometimes even better than dedicated translation engines, especially for languages with plenty of online content. However, when it comes to languages that have less text available on the internet, which are often called low resource languages, The LLMs tend to struggle more because they have less data to learn from. So, in our previous discussion, we explored writing tasks where you provide a prompt to a large language model and it generates a longer response. However, LLMs are also great for mini reading tasks. By reading tasks, we mean situations where you input a prompt and the model generates a response that is typically about the same length or even shorter than the input. Let's explore some reading tasks, starting with something I used all the time, which is proofreading. Prior to Grammarly and ChatGPT, when I write a piece of text, I read through it carefully through probably 3 or 4 times to check for spelling and grammatical errors. And even after all that, I still miss some mistakes. That's where these large language models come in handy. For example, you can prompt the LLM with a request like proofread the following text. I find that if you clearly state what you want, the model can help effectively. Or we might ask an LLM to check for spelling and grammatical errors, as well as awkward sentences, and then rewrite it with corrections. In this case, the model can spot errors like the misspelling of, let's say here, snuggle, and correct grammatical issues. When we want to be sure our writing is free of errors, we can use an LLM to proofread our work. It really helps to feel more confident about the final product. A second reading task where large language models or LLMs are very useful is summarizing long articles. For example, when reviewing related literature, I often copy paste articles into ChatGPT to get a quick summary. This gives me a brief overview and helps me decide whether the article is relevant enough to read in full. So, by quickly summarizing long articles, LLMs make it easier to identify useful literature that can serve as the foundation of our work. This speeds up the process of finding relevant sources for research or projects. I now frequently use LLMs to summarize articles or documents when I don't have the time to read them in their entirety. This is a simple and practical use case that you can try using any web based LLM interface. There's also a software application version of this concept that's becoming popular in businesses. Let me explain with an example. Imagine you're managing a customer service call center with many agents handling calls with customers. If you have permission to record these phone calls, you can use a speech recognition system to convert the conversations into text transcripts. When you have many agents talking to customers, you end up with large number of text transcripts. If you're trying to monitor or review what's happening in your call center, it's likely too much text uh, to read through manually. So, can you quickly understand what happened in a specific call? One way to use large language models or LLMs is to summarize entire conversations between agents and customers. For example, the model could generate a summary like MK401-27KX was reported as broken by customer 5402, cable identified as problem, replacement issued from this long transcript. If you apply this to all the text transcripts, a software application could automatically generate summaries for each call. As the manager, you can quickly review these summaries to spot any issues or trends that need attention. This system would be more efficient as a software application that uses a large language model instead of manually copying and pasting conversations one by one into a web-based LLM tool. Large language models can also be used to analyze customer emails in customer service interactions. For example, in our previous discussion, we show an LLM can help determine whether an email is a complaint and which department it should be sent to. This kind of system would typically be implemented as a software application powered by an LLM. Let's have a look into how you could build an application to decide which department to route a customer email to. You can start by writing a prompt that tells the LLM to read the email and determine the appropriate department for it. You would provide the email as input and specify the task. However, with a basic prompt like this, the LLM might suggest sending the email to a department that doesn't actually exist, like a complaints department. This happens because the LLM doesn't have enough context about your company's actual department or department names. So to fix this, you'd need to provide more specific information about your company's structure to guide the model properly. On the other hand, if you update the prompt to say, read the email and choose the most appropriate department from the following list, you give the model clear options to choose from. This way, when it processes the email, it will select the correct department, like routing it to the apparel department as per your choices. Building an application with a large language model involves this kind of trial and error. You might write an initial prompt that doesn't work perfectly, such as routing emails to a non-existent complaints department. When that happens, you simply revise the prompt, and that usually solves the issue. One last application we want to highlight is reputation monitoring, where you can use a large language model or LLM to track customer sentiment, whether positive or negative, over time. For instance, if you run a restaurant and customers occasionally leave online reviews or send emails describing their experience, you could use a prompt like read the following review and classify it as positive or negative sentiment. For example, if a review says the food was amazing or the servers were friendly, it would be classified as positive. By having software count the number of positive and negative reviews each day, you could build a dashboard to track customer sentiment trends over time. If the dashboard shows an increase in negative reviews, it can alert you to potential issues that need attention. So far, we've explored several reading applications, including proofreading, summarization, email routing, and sentiment analysis of product or service reviews. If you can think of any task where you'd like someone to read a text and quickly summarize or classify it, that could be a great candidate for using an LLM to assist. So in the previous presentations, we discussed writing and reading applications. Now, let's focus on chatting applications. Aside from the general purpose chatbots like ChatGPT, Bard, and Bing Chat, many companies are exploring the possibility of creating specialized chat applications. If your company handles many customer interactions or engages in recurring conversations of a similar nature, it might be worth considering whether a specialized chatbot could assist with those specific conversations. So let's take a look at an example. Earlier, we discussed a customer service chatbot that could efficiently take orders for a cheeseburger. Another example of a specified or specialized chatbot would be one designed to help plan trips. For instance, you could ask, how can I vacation in Paris on a budget? A bot could be built with expertise in travel to provide such advice. Today, many companies are exploring a wide range of advice bots. For example, bots are being developed to offer career coaching or cooking tips. These specialized bots are designed to excel in answering questions on specific topics. Some are conversational, offering advice, while others can even interact with a company's software systems to take actions like placing an order for a cheeseburger delivery. Another example of an action oriented bot would be a customer service chatbot. For instance, many IT departments are overwhelmed with password reset requests. If a bot could handle those, it would ease the workload of your IT team. A bot like this could send a verification text message to confirm identity and help reset the password. This type of bot needs to be capable of more than just generating responses. It must also be able to perform real world actions, such as sending verification text. Anyway, we'll have discussions later on how these kinds of chatbots are built to not only generate text but also take meaningful actions. Given the increasing interest from customer service organizations in chatbots, I'd like to share some common design approaches businesses are using. For this discussion, we'll focus on text-based chat rather than voice or phone-based systems. At one end of the spectrum, you have customer service centers run entirely by humans. Here, human agents are the ones typing messages back and forth with customers such as, welcome to Better Burgers. May I take your order? On the opposite end, you have systems where only chatbots interact with customers with no human involvement. Between these two extremes, there are common design points. One approach is having bots assist human agents. In this setup, a bot generates suggested responses, and the human agent reviews and either approves or edits the message before sending it. This design is often called human in the loop because humans remain part of the process, ensuring a final check before any message is sent. This helps reduce the risk of a chatbot saying the wrong thing as a human verifies the response. In our discussion later, when we talk about the large language models or LLMs can and cannot do, we will go over some of the errors they might make. This human in the loop design provides a safeguard against those potential mistakes. Another design moves further along the automation spectrum, allowing bots to triage messages. In this case, bots can handle easy inquiries and escalate more complex ones to human agents. For example, companies involved in sales are utilizing a bot capable of automatically detecting refund requests, which is generally around 10% of the chat volume. So the bot can be able to provide instructions for refunds without involving human agents, saving them time and letting them focus on more challenging customer requests. In many customer service centers, a single human agent might be chatting with 4, 8, or even 16 customers at the same time. By having these bots assist in generating responses or handling simple requests, human agents can manage a larger number of simultaneous conversations more effectively. Since bots can sometimes make mistakes, we look at how companies typically build and deploy bots in a safe way. Often, companies start by creating an internal facing chatbot. So, when developing a chatbot, the company's own team uses it, for example, to answer questions about travel or whatever the bot is designed to do. Since the internal team is usually more understanding and forgiving, if the bot makes a mistake, this provides a safe environment to test the bot's behavior without risking public errors that could be embarrassing for the company. Once the bot performs well internally, the next step is to deploy it with human in the loop system. This means that a human checks the bot's responses before they are sent to customers. This adds a layer of protection, ensuring that any potential mistakes are caught before the bot interacts with customers directly. After some time, if the bot consistently generates accurate responses, you might feel confident enough to let it communicate directly with customers. However, the specifics of this process will vary depending on your business. For some use cases, it may not be practical to have humans review every message, especially if there's a high volume of interactions. Ultimately, the decision to use a human in the loop system or allow full automation depends on factors like risk of the bot making an error and the volume of customer interactions. These are some common strategies companies use to deploy chatbots safely while balancing accuracy and efficiency. So, to sum up, we've been able to explore how large language models or LLMs can be used for writing, reading, and chatting. These categories aren't meant to cover everything LLMs can do, but they represent some of the key areas where you might find them very useful. While LLMs are capable of many things, they still have limitations. In the next discussion, we'll dive deeper into what LLMs can and cannot do so we can better understand their boundaries.